Welcome back to my YouTube channel. Today I am going to discuss another problem from CSIR Net Mathematical Science question paper December 2025. The problem from part C. Again the problem is from integral equation. The problem number is 101. It is given as let lambda belongs to R be such that the integral equation it is given y of x equal to lambda integral minus 1 to 1 5x t cube plus 4x square t plus 3xt y of t dt admits a non-trivial solution y of x such that y of 1 must be equivalent to 5 by 2. Then which of the following statements are true? Since the problem is from part C, more than one option may be a correct option. First option y of 0 plus y dash of 0 3 by 2. Second option y of 1 by 2 plus y dash of 1 by 2 7 by 2. Third one y of minus 1 plus y dash of minus 1 is minus 1. Fourth one y of 1 by 3 plus y dash of 1 by 3 equal to 14 by 9. The problem y of x equal to lambda integral minus 1 to 1. Both the limits are constant. This is Fredholm integral equation. We have to find the non-trivial solution y of x satisfying y of 1 equal to 5 by 2. Then check the option. Out of 4 options, which of the following options are true? The problem, what is given? Y of x which is equal to lambda integral minus 1 to 1 5x t cube plus 4x square t plus 3x of t y of t dt. We can write lambda 5x integral minus 1 to 1 t cube dt with y of t plus 4x square plus 3x integral minus 1 to 1 t y of t dt. I am taking this one as some C1. I will take this one as C2, which is equal to lambda 5x C1 plus 4x square plus 3x into C2. This is equation 1. Here, what is C1? Integral minus 1 to 1 t cube y of t dt. This is our y of x, which is equal to minus 1 to 1 t cube. From 1, I am going to write y of t. Replace x by t. 5 lambda t c1 plus 4t square plus 3t into c2 dt. This is y of t. Now integrate with limit minus 1 to 1. 5 lambda t cube into t power 4. If you integrate, it becomes t power 5 by 5. Limit minus 1 to 1 plus 4 C2 t square dt. If integrate, it becomes t cube by 3 limit minus 1 to 1 plus 3 C2 t dt, t square by 2 limit minus 1 to 1. One error. T cube into t square t power 5. If we integrate t power 5, it becomes t power 6 by 6 limit minus 1 to 1. Here also one error. Because of lambda outside the integral, here I will get lambda. Here lambda into 4c2 plus t cube into t 3 lambda c2 t cube into t power 4, integration of t power 4, it becomes t power 5 by 5 limit minus 1 to 1. Now simplifying, 5 lambda c2 1 by 5 1 power 5 minus of minus 1 power 5 plus 4 lambda c2 into 1 by 6 1 power 6 minus of minus 1 power 6 becomes again 1 power 6 plus 3 lambda c2 1 by 5 1 power 5 minus of minus 1 power 5. Here these two will get cancelled. This part becomes 0. Remaining 5 get cancelled. 2 lambda c2, because 1 power 5 is 1, minus of minus 1 power 5 becomes plus 1 power 5. 1 power 5 plus 1 power 5, it becomes 2 lambda c2 plus 3 by 5 lambda c2 into 2. This is c1. C1 minus here not C2, here C1, here also C1, C1 minus 2 lambda C1, which is equal to 2 into 3 by 5 lambda C2. We can write it as C1 1 minus 2 lambda minus 6 by 5 lambda C2, which is equal to 0. This is equation A. Similarly, what is C2? C2 is nothing but minus 1 to 1. Which one is C2? Minus 1 to 1 t of y of t dt. T of y of t. What is y of t? 5 lambda c1 into t plus lambda c2 4t square plus 3t into dt. Integration of t with t square, integration of t square dt, it becomes 5 lambda c1 t cube by 3 limit minus 1 to 1. Again t with t square becomes t cube if we integrate t power 4 by 4, 4 lambda c2 t power 4 by 4 limit minus 1 to 1. Again t with 3t square, integration of 3t square, 3 lambda c2 t cube by 3 limit minus 1 to 1. 5 by 3 lambda c1, substitute limit, upper limit is 1, lower limit is minus 1, 1 power 3 is 1, minus of 1 power 3, it becomes 2. This term 4 will get cancelled. T power 4 is 1 power 4, minus of 1 power 4, the term must be becomes 0. 3 will get cancelled. Last term lambda c2 into 2, because of 1 power 3 is 1, minus of minus 1 power 3, it becomes plus, answer is 2. Here c2 minus 2 lambda c2, which is equivalent to 5 into 2 by 3 lambda c1. Take c2 outside, 1 minus 2 lambda 10 by 3 lambda c1. We can rewrite it as c2 1 minus 2 lambda minus 10 by 3 lambda c1, which is equivalent to 0. This is equation B. For non-zero solution of equation A and B, we have determinant. Write the coefficient of C1 and C2 from A and B. For the first row, write the equation. From the equation A, write the coefficient of C1 and C2. C1 coefficient from the equation A, 1 minus 2 lambda. Coefficient of C2 from A, minus 6 by 5 lambda. From B, coefficient of C1, minus 10 by 3 lambda. 1 minus 2 lambda, coefficient of C2 from B. This is nothing but equivalent to 0. Simplify, 1 minus 2 lambda square minus 60 by 15 lambda square equivalent to 0. Simplification, it becomes 4. 1 minus 4 lambda plus 4 lambda square minus 4 lambda square equal to 0. 4 lambda square minus 4 lambda square cancel. We will get 1 minus 4 lambda equal to 0. Lambda is 1 by 4. This is our eigenvalue. For this eigenvalue, we have to find eigenfunction. To find eigenfunction substitute lambda equal to 1 by 4 in A and B. Substitute lambda equal to lambda equal to 1 by 4 in equation A and equation B. What is equation A? C1 1 minus 2 lambda minus 6 by 5 lambda C2 equivalent to 0. I am going to substitute lambda equal to 1 by 4. C1 1 minus 2 by 4. It becomes 1 by 2 minus 6 by 5. Lambda is 1 by 4. C2 equivalent to 0. 1 minus 1 by 2 becomes C1 by 2 minus 6 by 20, 3 by 10, C2 equivalent to 0. Which implies C1 which is equivalent to 2 into 3 by 10 C2. It becomes C1 equivalent to 3 by 5 C2. This is C1. Now I am going to substitute C1 equal to 3 by 5 C2 in 1. What is 1? Y of x which is equal to 5x, lambda is 1 by 4, into C1. What is C1? 3 by 5 C2 plus 4x square plus 3x, lambda is 1 by 4 into C2. 15 by 20 into x C2 plus 4x square by 4. It becomes x square plus 3 by 4 into x into C2. Simplification, 5 into 3, 5 into 4, it becomes 3 by 4 x C2 plus x square plus 3 by 4 into x into C2. Take 3 by 4, 3 by 4 into x into C2. Take C2 outside, 3x by 4 plus x square plus 3x by 4. By putting C2 equal to 1, it becomes 3x by 4 plus x square plus 3x by 4, 9x by 4 plus x square. Simplifying, it becomes some error. I am making error. 3x by 4 plus 3x by 4, it becomes not 9, it becomes 2 times 3x by 4 plus x square. Since I am taking C2 as 1, since by taking C2 1, 3x by 2 plus x square. This is our y of x. This is eigenfunction. Lambda 1 by 4 eigenvalue 3x by 2 plus x square is our eigenfunction for this problem. Also in the problem it is given as y of 1 must be 5 by 2. I am going to check what is y of 1. Y of 1 is 3 by 2 plus 1. 3 plus 2 by 2 becomes 5 by 2. Okay. Therefore, this y of x is 3x by 2 plus x square is our eigenfunction. Now I am going to check the option one by one. Option 1, y of 0 plus y dash of 0 must be equivalent to 3 by 2. What is y of 0? Y of 0 means 0. Y dash of 0 means 2 into 0 plus 3 by 2, which is equivalent to 0 plus 0 plus 3 by 2. Answer is 3 by 2. Option 1 correct option. Now I am going to check second option, y of 1 by 2, y dash of 1 by 2. Option 2, first to find y of 1 by 2. Y of 1 by 2 means 3 by 2 into 1 by 2 plus 1 by 2 the whole square. It becomes 3 by 4 plus 1 by 4. Answer is 1. Now I am going to find y dash of x. 2x plus 3 by 2. Y dash of 1 by 2. 2 into 1 by 2 plus 3 by 2. 1 plus 3 by 2 is 5 by 2. Adding this y of 1 by 2 with y dash of 1 by 2. Y of 1 by 2 plus y dash of 1 by 2, which is equivalent to 1 plus 5 by 2. Answer is 7 by 2. Second option correct option. First one correct, second one correct. First option correct one, second option correct one. I am going to check the third one and fourth one for this problem. Since the problem is from part C, more than one option may be the correct option. I am going to check the last two options, third one and fourth one. Now y of minus 1. Y of minus 1 means 3 by 2 minus 1 plus minus 1 the whole square. Y of x is 3 by 2 of x plus x square. Answer is minus 3 by 2 plus 1. 1 minus 3 by 2. Answer is 1 minus 3 by 2. 2 minus 3 by 2 minus of. This is y of minus 1. Now I am going to find y dash of minus 1. Then add. What is y dash of minus 1? y dash of minus 1 is 3 by 2 plus minus 1 the whole square, which is equal to 3 by 2 plus 1. Answer is 5 by 2. Y dash of minus 1 means 3 by 2 plus 2 into minus 1. Since y dash of x is 3 by 2 plus 2x, 3 by 2 minus 2, 3 minus 4 by 2, answer is minus of. If we add y of minus 1 with the y dash of minus 1, we will get y of 1 plus y dash of minus 1 minus of minus 2 by 2, answer is minus 1. Option third one is also correct one. Now I am going to check whether the fourth option is the correct one or the wrong one. Option 4. Option 4. Y of 1 by 3, y dash of 1 by 3. Y of 1 by 3, which is equal to 3 by 2 into 3 plus 1 by 9. It is 9 by 2 plus 1 by 9. Eight nines are 72 plus 2, 74 by 18. Here not 3, here 1 by 3 plus 1 by 9, which is equal to 3 cancel, 1 by 2 plus 1 by 9, 18, 9 plus 2, 11 by 18. Y dash of 1 by 3, 3 by 2 plus 2 into 1 by 3. 3 by 2 plus 2 by 3, which is equal to 9 plus 4, 13 by 6. Now adding these two, 11 by 18 plus 13 by 6, since the last option is y of 1 by 3 plus y dash of 1 by 3. 18, 11 plus 39, 50 by 18. But we have to get 14 by 9, but we are getting 15 by 18. Option fourth one is the wrong option. For this problem, option 1, option 2, option 3 is the correct option. Last option, fourth one, is the wrong option for this Fredholm integral equation. I will upload more problems from CSIRNet Mathematics Science December 2025 question paper. Subscribe my channel, like my channel, share my channel to your friend. Thank you.